What's going on, data devotees? It's Jameson here. This video is on labs in general, and what we're actually going to do in this video is, first of all, discuss and demonstrate where to find labs, discuss the different components of a lab, so it's not only the lab template itself, which you will add to, modify, and sort of complete in RStudio, but also the resources that you'll have available to you, such as the instructions and the original data. And then we're going to answer a few different questions in this initial lab and anything else that you might need to know, especially about formatting your responses and making sure that your submission is up to snuff. And so without further ado, let's just jump right in. If you haven't yet and you find these videos useful, don't forget to subscribe. We do come out with new ones, and as far as I know, although we do have a large repertoire of videos for CPP 526, this is the only video that walks through the very first lab. So yeah, let's jump right in. So I'm on the home page here for DS for PS, and of course, remember, make sure you're in the summer 2020 homepage, and I'm going to click on course schedule. We can scroll down, and expand the Lab 01. Now that's going to give us two different options. There's, first of all, the Lab 1 instructions, and secondly, we have our Submit Lab. So I'll let you all handle the submission process on your own, but by clicking on Lab Instructions, it takes us to this page. Now, first of all, we've got this big old download button, and that's kind of like, whoa, where'd that come from? If we click on it, that's actually going to open up a template that in RStudio we can access. And it's quite nice. It has a lot of stuff already there for us. In fact, we can go ahead and click the knit button, and you knit these R Markdown documents for them to come out compiled, essentially. So it takes all of the code that we have here and it compiles it into a nice, neat publication ready documents or HTML web page or whatever it is you're going to be knitting it to. We could knit to PDF, HTML, a Word document, and that sort of thing. So cool. So I just pressed the knit button without anything else, and everything is already here. It does say delete text below this line before submission. And it gives you a few useful functions and different instructions and notes on knitting and things like that. So cool, that's very helpful. And let's jump back into the instructions page. So first of all, it lets us know what functions we'll typically need to use to be able to answer all of the challenge questions. And it's also going to give us a kind of a preview of the data that we're going to be using. So in Lab 1, we use the city tax parcel data from Syracuse, New York, and it gives us the first 10 observations. Now, this was from a much larger data set, and actually we might be using that same data set, which is actually still quite large. I think we use a subset of it, a smaller data set, if you will, for Lab 2. So it's nice to get accustomed to this data, and you should be able to find that helpful. If you click on Data Dictionary, it's going to take you actually to the original assignment. And go ahead and click on DataQ's Open Data Portal. Now, this is the true origin of the July 2018 tax parcel data that we're going to be using for Lab 1. And it's never a bad idea to be able to explore the documentation for the data that you're going to be using. Of course, there are all sorts of different ways in R to be able to explore your data. That's called exploratory data analysis, or EDA. But there's nothing like good documentation to be able to explain things that the data simply aren't going to be able to show you if you just look at a table with a bunch of rows and a bunch of columns. What is the origin of the data? What are the units of measurement? How were the data collected? Is there any pre-processing that's been done to the data that you should be aware of, as opposed to getting raw data? So these are all kind of important questions, and oftentimes good documentation will answer those questions. Here we can see what are called attributes, but that's just another name for variables or columns or fields or really anything else that you might find, any other name for a column really. And this tells us the type of variable it is. So we've got numbers versus text versus unique IDs, etc., etc. And so we can actually click on any of these and it will give us so long as it's numeric, and it will give us a histogram and show us the distribution of those numeric values. So again, a histogram is what you would use to visualize the distribution of a single variable, and it just shows you the number of occurrences in your data for that variable. So just a good idea to familiarize yourself with your data before you start any lab. And what's more, we're going to be using this in lab 2 as well. So take the time to get to know it a little bit better. It's never a bad thing. So great. Loading data into R, we've got some really helpful tips here. Essentially, we're taking the URL. Now, if we were to visit this URL, it's giving me a hard time copying and pasting it. Let's see. Can it be done? Okay. I'll cut off the beginning of that. And I'll also cut off those quotation marks. Now, if I press enter, this should download. It doesn't. No, but this is actually the CSV, or the comma separated value file, that you'll be reading into R. So what we do is use, now it's giving me trouble highlighting it again, but we use function read.csv to be able to read in that URL. And we just let it know with this argument, string as factors equals false. All that's telling R is that, hey, if it's a text value, don't count it, for God's sake, don't count it as a categorical variable, which is called a factor in R. So all we're doing here is saying, hey, read in the CSV data from this URL and make sure that any of the text data that's read in is not stored as a categorical value. And then we're going to store that in an object called dat, right? Now, this is a useful term to be able to explore your data. Function summary, and you can call that on a specific variable, in this case acres, or you can call it on an entire data set as well. So what's that look like in R? Well, again, they've got these chunks here. These are called code chunks, what's happening in the gray. And this is your machine-readable code. This is what R is going to recognize as what you want. You're essentially telling R, hey, interpret this as you would any other R code. Anything outside of these chunks is more explanatory. It's more for exposition, for you to be able to talk to your audience. And the way you can think of this is anything in white is human-readable language, and anything in these gray code chunks is machine-readable language. Now you can run these simply by pressing Control and Enter. And it's a big data set, so it'll take a second for dat to load in. And I'll show you a different way to run those soon. Cool, so dat loaded in. We can even click on it, and that takes us to the entire data set to be able to view it. So yeah, there's 41,000 rows in here and 29 different columns, so it did take a second to load in. But beyond being able to just simply highlight and press Control and Enter to be able to run that code, another thing that you could do is actually press this little green play button here, and that's going to run the chunk, run the code chunk, if you will. There are other options. For example, in the run button up here. Now, if we pressed run, we'd, I believe, run the entire document, which we don't necessarily want to do. But you can also say run the next chunk, run the setup chunk, which is this one right here. So you can see it says setup. Run all chunks below. So if you're halfway through the script and you want to say, okay, I only want to run the code that exists below this, we can select that. Or if I only want to run the code that exists above this, we can also select that, or of course, run all. So there are these different options to be able to run this code. Those are code chunks, and typically in a R Markdown document, like you see here, you'll see an initial setup chunk. And this is essentially establishing options that are going to tell R all of the different rules that you want to apply to each time you have a code chunk. So these are kind of global rules. In other words, you can set up a global set of rules in the very beginning of a document or in the very beginning of a script, and then those global rules will then apply to any code that you type after that, including code chunks. And that can be extremely helpful for making your code a lot neater, reduce a lot of extra typing that you have to do and things like that. So what is this global options chunk really telling us? Well, first of all, echo equals true. So what that means is, let's knit the document. All right, there we go. So echo equals true means that we not only show the output of a code chunk, which is typical, we also echo the code that was used to be able to create that output. So here we have an example of a code chunk and some code inside that code chunk, and echo equals true makes it so that we repeat the code as well as printing the result. So message equals false and warning equals false. This is essentially a way to suppress or hide any sorts of messages from R or any sorts of warnings from R that it would usually let us know. Let's say, for example, we're reading in data and it's read in some sort of a variable that it's having trouble interpreting. So it's going to say, well, we don't really know what this is, so we're going to interpret it simply as text and we'll leave it up to you. That's going to throw a warning, and that warning that R is telling us is not going to appear because we've suppressed it, right? So occasionally you get warning messages. If you don't suppress them, they do appear in your final outputted document. Cool. So on around line 104, you'll see delete text below this line before your submission. I would review all of this. It's going to be extraordinarily helpful when it comes to understanding exactly what you need to know for this assignment. But always, 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 before you submit your assignment or before you compile it, make sure that you do delete that particular chunk, because that is, or that entire section, I should say. It has chunks. It's got some human-readable language like we see here, and chunks like we see here. And so do take care of that. So now that I've removed that, I'm going to hit knit again, and we'll see how much shorter our document is. Of course, it's probably taking a minute to knit because we're essentially reading in or downloading that data each time. Cool, so this looks a lot neater. It's got your name. It lets us know it's lab 1. It's got the system date. That's automatic. It's got the data dictionary, a little header about what the data look like, and then it has each question and each answer, as well as what a code chunk would look like. So let's go ahead and, I actually made the font size larger here, but it's almost obnoxiously large. It's kind of making it difficult to concentrate. Let's try 16. Okay, that's not as bad. All right. Cool. So once we jump into solutions, we're going to need to essentially perform different operations, and we need to provide our code as well as write out the answer. So how many text parcels are in Syracuse? In other words, what are the data set dimensions? So there's a lot of different ways that you might be able to solve this. But the most important thing is that whichever way that you solved it, you've inserted this code chunk, you've shown your code, and then you've also written out the answer here in the answer line. So you'll notice also that these code chunks don't exist for later questions. So you will want to probably insert those code chunks, and I'm just going to do that en masse right now. All I've done is just highlighted a code chunk that was empty, and I'm just copying and pasting it. Now, if you wanted to, there is a little extra option here. You can click Insert, and you simply select R. Yeah, I was confused for a second. I thought it would say like R code chunk or something. Typically, I just type it out. So if you click Insert, it will automatically open up a code chunk for you. Insert and then R. The other option is that you can actually just type it out. So there's 3 backticks, whereas the backtick key that's located typically to the left of the 1 key on a keyboard, on a regular keyboard. And then in curly braces, we do we do these curly braces with R in it, and then we do 3 more backticks. So there, we've made a code chunk. We can add extra options to it if we want. For example, echo equals false. And there are all variety of different options you can add to these different code chunks. And that's up to you. They get more advanced when we're going to be doing like, working with images and things like that. So I wouldn't worry about it. Keep all your code chunks relatively simple. And okay, cool. That's pretty much all there is to say about this. So let's look at number 1. How many text parcels are in Syracuse? So we've got a pretty powerful hint there, dataset dimensions, right? So there are a few different ways to get the dataset dimensions. You can get them, for example, if we were to use str, which is the structure function, and we simply put in the name of the object, which contains our data in parentheses. And I'll just press enter. And at the very top of that, that's actually going to give us 41,502 observations and 29 variables. So that's the answer we're actually looking for right there, is the number of rows, because each row represents a text parcel. Or does it? Chun chun chun! Well, anyways, it mostly does. It mostly does. But yeah, so cool. That's one option to be able to do that. Again, that's structure, function structure, and then object dat. So what's another way? This one's a little bit more straightforward and to the point. We can use dim, which is the dimensions of a data set. In other words, just kind of like you have the dimensions of a room where you do the length and the width and the length, or you might have the dimensions of a cube or a 3-dimensional object with like width, length, and height, or something to that effect. So this provides the dimensions of a data set, and data sets have 2 different dimensions to them, the number of rows and the number of columns. So if we type in dim and then the object's dat inside parentheses, it lets us know 41,500 rows, 29 columns. We can even get even more specific and mention that we only want the first element returned. So cool. So just for review, there's structure, which prints out way more detail than is necessary, because it's actually telling us every single variable in here, along with the dimensions of the data. We could type in dimensions, which is much more straightforward. And it simply gives us the number of rows and number of columns. And then what's more, we could even do something like nrow, which tells us the number of rows. That's even more to the point. So yeah, those are probably the quickest and most straightforward ways to get the dimensions, and with the least amount of ink wasted, probably either function dim for the dimensions or nrow for the number of rows are going to be able to get that answer for you. So great. Now I've shown the code that I've used to answer this question. It's quite simple. We even add some space for it to be more visually decipherable for us and for anyone else who's looking at the code. Now we're ready to answer this. There are 41,000, and I'll put this in bold here, 41,502 tax parcels in Syracuse. So cool. That answer is done. I'm going to knit that. Let's see what that looks like. Man, I should really cache that data. It takes forever to load in, read in. Okay, cool. All right, so we've got answer. There are 41,502 tax parcels in Syracuse, and we've shown our code in the code chunk, and because echo is turned on, it shows the original code that we used, and it shows the output of that code as well, 41,502, which is just simply the number of rows in the object dat, right? So I'm actually going to go ahead and put in a little argument here, cache equals true, so that way we don't download that data each time. Let's see if that worked. Now it'll take just as long to initially do it because now it's re-downloading it and caching it. And again, we've just added this option in the code chunk, cache equals true. Okay, so that took a minute to do. Not a minute, but 20 seconds. Now let's try it again now that we've cached our data set. And Bob's your uncle. It pops up in a matter of seconds. So you might want to consider adding that argument to the data call when you read in your cached data. Yeah, that just makes things easier and quicker. So, cool. There's a little bit of an advanced technique that you can use. So, I'm kind of hesitating whether or not I want to show it to you. Let's do include equals false. So this is actually going to hide that row of data. And now I'm going to take n row and I'm going to assign that to this new object called x. We're using the assignment operator. So in other words, we're taking the output of n row, which is 41,502, and we are going to assign 41,502 to the value x. I can do that right now. And it appears here. And if I type x, boom, 41,502. So x is more or less, in a matter of speaking, containing that value. And it can contain multiple values. Dat, for example, contains an entire data set. So that's an object, and that's the value that we've assigned to it. So now we can actually do something where in the middle of the code, we do these backticks, and then we do these curly brackets, and then we put r, and then I'm going to put object x. Let's see if I did that right. I might have done that wrong, but let's find out. Yeah, I did. Okay, so I think it's curly bracket, and then it's x. Dang it. Dang it, Bobby. All right. So if we need help, we can always go to, it's been a while since I did inline code. So I just went into the cheat sheets. Help. Cheat sheets are Markdown. Cool. Inline code. There it is. Okay, cool. Oh, we just do a lowercase r. That's it. All right, let's give it a try. There we go. So object x has appeared in line or in line in the line of human-readable letters, we have this machine-readable little variable, and then that will change dynamically. So if we were to, say, multiply x by 100, so that's got to be at least 4 million, I would imagine. So cool. Now that's going to knit as a much larger object. Cool. Yeah, it even puts it in scientific notation because it's such a large number. So again, how we've done that is just simply a backtick, a lowercase r, and then some sort of object name. I mean, we could even put the entire expression inside that as well. So again, this is a little advanced. You don't really need to know this to be able to complete your assignment, but it is really one of the more powerful uses of R Markdown to be able to create dynamic and flexible reports that all update with your data. So cool. Anyways, I'll put a skip that section chapter. So let's take a look at question 2. So how many acres of land are in Syracuse? Sum over a numeric vector. So for this, you're going to need function sum. And also, let's take a look at the different variables. It's saying over a numeric vector. Well, what numeric vector would show us the acres? So we could do names, dat. Cool. So I can actually see it right off the bat. There's a variable called acres. So if we wanted to, we can do dat acres, and this might return it. It might not. Let's find out if it does. Okay, I'm surprised a little bit. Usually when you use something like sum, you want to add an extra argument in there, and it's this little trick called na.rm equals true. So na.rm means remove NAs, or remove missing values. So if there was a missing value among all of the different acre values in our data set, then this would actually come out as missing as well. It's kind of strange like that. R is letting you know, hey, there's a missing value here. We want you to be aware of it, and we want you to explicitly give R permission to be able to ignore those missing values. And only once you've acknowledged that there's missing values and that you're okay with ignoring them by using na.rm equals true, then we'll go ahead and compute the sum of all those acres. So once again, we can do the total acres of12 12,510 acres of land in Syracuse. And if you want, you can put that in bold. That's always nice when you can format these. This is especially nice for me, although I'm going to be looking at a combination of your code and your actual lab itself, the output. And these are opportunities, again, to be able to create a data product and not simply do the assignment. So it's always nice to get some practice in formatting, and then this is just an example of that. So if I go ahead and click knit, cool, we didn't change this up here, but we did manually type that in. Now 12,510 acres of land in Syracuse. Cool. All right, so how many buildings are there in Syracuse? So now it's a logical vector, and we have to use the sum function. So again, you're going to be using sum. And when it comes to the data set, here's a trick, by the way. If you type the name of the data set object, in this case it's dat, which we can see up here, and you type in that $, if you press tab, you can cycle through every single variable that exists in that data set. So how many vacant buildings are there in Syracuse? Let's see. Which one here? There we go. So there's vacant bill. So that looks like the variable that you're going to want to use for this. And let's see what it looks like. Now, before we print out what that looks like, Logical stands for true and false values, and also missing or NA values. So a logical vector is just a series or a sequence of trues and falses. So what's that look like if we were to print out a giant 41,502 individual values of trues and falses? Well, it looks like that. And it looks like we've got some missing data there as well, which we're going to have to keep in mind because we're going to be using the sum function. So false, 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 false. And then a true in there. There's a couple trues. So in other words, this is saying, hey, on that tax parcel, is there a vacant building? If there is, it's true. If there's not, it's false. So this is actually kind of some good news that we're seeing mostly falses here. Yeah. So the thing about trues and falses is that under the hood, if I were to convert a false into a numeric value, I'll bring this down into the console here. What would happen if I were to convert a false into a numeric value? What do you think is going to happen? It becomes a 0. Okay, so false is equal to 0. What does true equal? What do you think? Well, true actually equals 1. So true and false, this is actually binary, these logicals. And because of that, when we take a sum of, let's say we have true, true, false, true, false. Okay, so that means we've got 3 trues and 2 falses, and we use function sum on that. It gives us 3 because there are 3 trues. And what if I change this last false to another true? Well, underneath the hood, remember, true is equal to 1, so this is going to give us 4. In fact, we can even take the average if we wanted to get really crazy by using function mean, and that tells us the percentage of the trues and falses, or the proportion of trues and falses that are actually true. So in this case, 80%, or 4 out of 5, are true. So you're going to be using similar logic here. Every single time that there's a vacant building or where it's true, then that will count as 1. So if you were to insert this variable into sum, then you will get the total number of trues. But don't stop there. Make sure that, let's say this is your variable that you're inserting. I'm not going to do it for you because I'd basically be just giving completely everything away. Make sure that you do na.rm equals true. That is, if there's an NA or missing values in this variable, we want to remove it. We want to ignore it, and we want the sum of trues ignoring those missing values. So make sure you're using that. And of course, type out your response. Something to that effect. Okay, what proportion of parcels are tax exempt? Well, this is the same thing that we did here. Tax exemption is also logical. It's a series of trues and falses. So we'll do dat. So there's tax ID, but there's tax exempt. So what does that look like? Trues and falses, right? So again, if we use mean on a series of trues and falses, we will get the proportion which equals true. And in this case, it would be the proportion of values which are tax exempt. But just like sum, mean has an argument in it that we need. Let's say x equals 1, 2, and 3. So the average of 1, 2, and 3 is equal to 2. But if we have a missing value in there, what's going to happen? It's going to give us a missing value. What if I tell it to ignore missing values? Well, na.rm equals true. Don't forget it. We did it with sum, and now you're going to do it with mean. And that's the same with max. It's the same with min. It's the same with median. It's the same with quartiles. So all of those, just don't forget this handy dandy little argument here is going to save your rear countless times. So cool. Now again, we're just going to be calling mean. Now a way to abbreviate trues and falses is with T's and F's. You don't have to do that. So here it's telling us among these three values and ignoring the fourth value, 33% is true and then 66% is false, right? So you're going to be using, instead of this right here, you're going to make x equal to the variable that represents the tax exempt status. And so again, it would be dat $, and then some variable that you've chosen there. And of course, X% of parcels are exempt, or something to that effect. Okay, so which neighborhood contains the most tax parcels? So this is a specific variable that you're going to be using, and you're going to be using function table. Now with table, you don't have to worry about na.rm or anything like that. So what does table do? Well, it's actually going to tell you the amount of unique values in a variable and how many times those values appear. So let's go with zip, right? So I was actually kind of surprised when I was reviewing these data earlier, because there are a lot of zip codes that don't really appear in Syracuse, and I'm wondering if that's an issue with the underlying data or something. But I swear some of these zip codes, I just don't recall them being in Syracuse. I don't know. It's very strange. Maybe that's the owner zip code or something like that. So one good kind of categorical, and in this case, in this data set, categorical data is age range. So when we use the function table, and again, we specify the data set object, and we use the $, and then specify the variable, each of these is the value that exists in this variable, and then underneath we see the count of how many times that value appears. So buildings that are 91 to 100 years old, there are 7,089. Buildings that are more than 200 years old, wow, this is pretty cool. 201 to 210 years old, there are 15 of those. 3 buildings between 221 to 230 years old. That's neat. I wonder what those are. So again, we're just using table, the dataset name, we're signaling that we want to extract a variable, and then we do the name of the variable. So table with one variable, and in this case, read the question and try and figure out what's the correct variable to use there. That'll get you the right answer. The next one is very simple as well. Pretty much, which neighborhood contains the most vacant lots? And so you're going to need 2 different variables for this. So first, one that tells you the neighborhood, and the other one that tells you vacant lots. Now I'll give you a hint. That variable is called land use. Cool. And what that looks like is this. So you have all of these different values, and each of those values represent how that land or that tax parcel is being used. So here's a nice clue for us. We're looking for the most vacant lots. So one of those values is vacant land. And then we have, of course, a bunch of single families. We've got some apartments. We've got some commercial uses. We've got schools, so on and so forth. And in fact, we can use function table just with that variable alone, land use, and we can see each unique value of land use and how many times it appears in the data set. So looks like single family takes the cake with 24,000 different tax parcels. Next in line looks to be about 2 family tax parcels. So maybe those are kind of, what the hell are they called? A duplex. I grew up in one. Come on. Right. So, so what you're doing here is you're going to use this variable, and then you're going to use another variable, and all you have to do is separate them with a comma, because you can call table and land use, and that kind of creates a cross tab. So what we can do, just for the sake of demonstration, is we can also use age range. Cool. So this is listing out all of the different ways that land is used, and then we've got the age here. Oh, you know what? This is kind of interesting, because I bet there are some really old religious buildings here. Nope, not in the 200-year-old categories, it looks like. But, darn, that's disappointing. But I'm sure there are some houses here. Certainly no commercial buildings that are in the 200 years old. That would be quite historic. And so interesting things like that. So again, to solve this, you're going to essentially simply use the table function and then enter in the 2 necessary variables. Of course, you're prefacing them with the dataset object name and also the $sign to let R know that you're pulling this variable from that dataset. And don't forget to separate them with a comma. And then lastly, of course, neighborhood X contains the most vacant lots, or something like that. So you save that, you can click knit, and you can, this is what I get for not completing my stuff. What was it? What was the error that it threw? Let's see, Markdown. Line 78. Piece of cake. Okay, yeah, we didn't specify a variable here. I'm just going to delete that. Cool. We'll probably get another one. Really? Oh, yeah, doesn't recognize X because we didn't apply anything to X. Get rid of that. Okay, so just so you know, that's a good hint too. It's going to tell you the line where it's getting caught up if it's not properly knitting. Obviously, you do not want all this output. Holy cow. But when you are done with this, you're going to turn in not only your knitted HTML document, and you do that again by hitting the knit button, but you're also going to turn in the .rmd file. Now, when you save these, just a final hint here is that you want to end it with .rmd. If you don't do that, it's not going to register as a R Markdown document. If you want to just save it as a script, you would just save it as .r. Here, you're going to save it as .rmd. Make sure that you do that. Make sure that you include your name, etc., etc. You're going to turn in your script, and you're going to turn in your compiled knit kind of final product there. So, yeah, that is how you work with labs, and that's kind of a pretty in-depth walkthrough of the first lab. Hopefully that answers most of your questions, and if you found this useful, feel free, again, I strongly recommend subscribing to this channel because I'll be coming out with more videos, and hopefully you do check this out. Anyways, in the meantime, enjoy the rest of your weekend, and take care. Good luck with your assignment.